Now, we're dealing with interest problems, and in fact, we backed up a little to go to the textbook and solve some simpler problems, to ask some easier questions than we handled in class last time. So it's worth a little review. Getting the foundation straight is always helpful. Now, here you will recognize something like the interest formula we were working with before, but not so complex. This is what's called the simple interest formula, and simple interest is perhaps just what you'd expect. If an investment returns a certain amount of money in a period of time, but you don't go through the complexity of adding the return back into the principal and therefore changing the rate of growth. How can you handle the mathematics of that? Well, you calculate the interest by simply taking the principal. You can call that the present value because that's the subject of this topic, that the value of money keeps changing over time. Take the principal, simply multiply it by the rate and the time period. And this easy arithmetic gets you your answer. So to go back to the problem we were working with before, at least a similar one to the one we dealt with in class on Thursday. If we've got $1,000 in principal and it's earning 2%, how much interest does it earn us in 2 years? So the answer is simpler than the answers we were getting. It gets us $20 per year. So, of course, the final total is going to be $40. The only trick to that, perhaps, is that we have to remember how percentages convert into decimals. Percentage is just really a two-place decimal. It's a fraction over 100. We multiply how much we have, the portion of itself it's going to generate, that would be the rate, and the number of times we're going to do that all together. And we end up with our answer, $40 over 2 years. Now, to look ahead when we get to compounding interest, that is, not simple interest, but the more complex problem we dealt with before, what happens when your investment makes money and the money it makes is added to the money you've already got so that it makes money even more quickly? Then we wonder, well, how often do we tally up what we've made? How often is there a reckoning? If you invest $1,000 today, then it earns interest over time. And you might have an annual rate that you are expecting. We've been dealing with 2% per year. But does that mean that the investment behaves as though you've made nothing on the investment until the full year is up? Is the value worth $1,000 still after a month, and $1,000 after 2 months, and 3 months, and 6 months, and 11 months? But you finally get your $20 after the 12th month? Or perhaps would the accounting happen? Would you tote up who owes who owns what, who owes what amount? Would you do that every 6 months? So suppose you made your $1,000 investment on January the 1st, and you were expecting 2% per year. Suppose that at June 1st, when half the year had gone by, you stopped to do the accounting, how much had your investment made so far, and that amount was added to your principal to make money in the future. Now, how much would you make in those 6 months to be consistent? Well, clearly you wouldn't make the $20. You have to wait a year And what you're earning, the excuse for you earning money with your money is that you leave it there over time when you could be using it for something else. So you clearly don't get the $20 at the 6 month mark because you aren't owed that until the full year is up. But it also doesn't seem fair that you should get nothing because you've done half the work. And this is easy to figure out. You were expecting 2% of your money over the full year, $20. So in half a year, you should get half the amount. And so you can think of this as the question of what do you get if you had invested your money instead of for 2 years? What if you'd invested it for 4.5 years? No. We could think, well, in 4.5 years, you should also get $40. And if we're sticking with simple interest, you can imagine you made your $1,000 investment. Every once in a while, they count up how much interest you're owed, and they simply give you that money. You maybe put it in a jar, and you're waiting to see how much it adds up to at the end of the period. Well, the number of times you do the accounting shouldn't change the total. So, just because you stop every once in a while to see where you are, you shouldn't change at all the rate at which you're earning money. So if you earned your interest in half years rather than full years, but everything else is about the problem is the same, then the final answer should be the same. You should still be getting $40 when you're all done. Now, this obviously means that you'll have to adjust the rate because you think, well, I'm being paid my interest for half years, so I should earn 2% every half year. Then that would throw off your total. That would be another version of that same mistake I was talking about before, thinking you get paid the full amount in half the time. What do we have to do? Well, obviously we're going to have to cut the rate in half, because if you earn 2% over a full year, you should earn 2% divided by 2. That is 1% over half a year, and we should have an equivalent equation. If you put the same amount of money down, $1,000, if you earn half the rate for twice as many periods, you should end up in the same place. And indeed you do, with $40. Now, that conversion is going to be necessary when you do the homework problems, which play around a bit, with the periods of compounding. And what you have to remember is that to do this properly, if the rate is an annual rate, it tells you how much you earn in a year. And if the compounding period, if the time until it's calculated how much you've earned so far is different from a year, then you need to adjust the rate to fit the period. If you make it shorter, you can say you compound every 6 months, that's twice a year. So you will have to divide the rate by 2, just as you multiply the periods by 2. And if you compound monthly, as you put in your investment on January 1st, and on February 1st you make a reckoning how much interest have you earned so far, and March 1st and April 1st and so on. until your investment is done 2 years later, then what you're doing is compounding 12 times a year. And if each period is 1/12 of a year, you're going to have to divide the rate by 12 so that it accurately represents your annual rate over a less than annual period, or a period shorter than a year. And then, of course, you multiply the periods by 12 because there will be 12 of them for every year. You could go the other way. You could decide to wait 2 years before you compound, so you'd only do it once in a 2-year period. And then you'd go the other way. You double the interest because you're not stopping to reckon how much it is until twice as much time has gone by. But you divide the number of periods in half, because if the period is 2 years long and the loan goes for 2 years, that's only 1 period. So this is fairly simple, but also fairly trivial. With simple interest, it doesn't change the amounts. But when you actually get to compound interest, when you're putting back the money you made before to make more money, then it does matter, and it does, in fact, change the amount of money you get. If you think about the problem, if you make $1,000 investment and you consider that you earn 2% per year, you leave it in for 2 years, but during that whole 2 years, you never stop to think, how much money have I made already? Then you simply make the simple interest, because you never get around to that step of putting the interest you've already made back into the principal to earn you that much more money. However, if you make the same deal, $1,000 at 2% per year for 2 years, but you do stop in the middle after 1 year has gone by to calculate how much money you've made, then you earn a little bit extra. That's how we got to this figure from before. If you've made this investment, $1,000 at 2% per year for 2 years, compounded yearly, we could say compounded annually. That is, you stop after each year, find the interest made already and put it back into the loan. You end up with a little bit of extra money, an extra 40 cents over simple interest. It's a trivial amount of money. But when loans go a long time and are for lots of money, it can make a big difference. So that we saw that if you left this investment go at the same rate for 50 years by simple interest, you would have doubled your money. But by compound interest, you would have gotten not $2,000, but $2,700 in some dollars, almost 3/4 of your principal extra. So compounding does matter when we're talking about realistic numbers.